Hey guys, Mr. T here again. This video is again on trigonometry, but this is finding the angle instead. So last video was about finding the sides, unknown sides. Now it's finding the unknown angle. So once again, because the trig ratios link the size of the angle and the length of the sides in a right angled triangle, you can use them in a different way to find the size of the angle. If 1, 2 of the side lengths are known, you need to know 2 side lengths, and 2, the triangle is right angled. So like I said before, all of this relies on the triangle being right angled for it to work. So once again, the process is very similar. You calculate what you do know and use a trig ratio, but this time it involves 2 known sides. You don't need to have a trig ratio that involves an unknown side and a known side this time. The thing that you don't know in this particular use of the trig ratio is angle, so you need to know 2 sides. The problem here is your calculator doesn't let you divide by sine, cosine or tangent ratios. Instead, you have to use the inverse sine, cosine and tangent. How do you access that? You press the second function of the sine, cosine and tan buttons. So you'll notice on your calculator these buttons here, sin, cos, tan, you need to access the second function of those buttons, and that is accessed using the second button on the calculator, which is here, that second button. So when you press that, unfortunately this isn't animated, this is just a screenshot. If you press the second button on your calculator, you'll find that the sine, cosine and tan buttons become sine -1, cosine -1, and tan -1. So they'll change slightly and there'll be -1s on top of them. So those are the inverse functions. So that's what you're going to be using when you're finding the angles. You use them straight up, sine, cos, and tan, if you're finding sides, but when you're finding angles, you need to use the inverse by pressing second. The other thing you need to make sure is you need to double check. Your calculator must be in degrees mode. So you need to look for an indicator sign that says DEG in a box somewhere. Most calculators will have that. So you'll notice that here it's really tiny, but here in my calculator screenshot it says DEG. That means the calculator is in degrees mode. If you find that the indicator says RAD, which is radians mode, you need to find the degrees button and press it to put your calculator in degrees mode. So you want it to be like this. If it says radians, what you're going to notice is that this button here that says radians will actually say says RAD, will say DEG, which is degrees mode. So this button will put it into the mode that it says it will be. So right now, because my calculator is in degrees mode, this button will put it into radians mode instead. If your calculator is in radians mode, if it says RAD here, you'll find this button says DEG. So you need to press that and set your calculator into this mode. Okay, so you need to double check when you're doing this trigonometry, and you're not going to have to use radians mode unless you're doing the really hard maths later on. You need to double check that it says DEG. If it doesn't, press the button here which would say DEG, and it will fix it and put it back into that mode. Whew, okay, so that's that out of the way. We need to actually make a start on the actual maths that you need to do. So find the size of the angle theta in the triangle below. So once again, we need to label sides. Theta is what the angle we're trying to find. So 5 centimeters is opposite to it. This is the hypotenuse, which we don't know, and this is the adjacent. So we need to have 2 side lengths that we know. It needs to be a right angled triangle. All those conditions are met. So we just need to work out what ratio involves the unknowns. Oh, sorry, the known sides. So ka, toa. So sine involves the opposite and the hypotenuse, and the hypotenuse I don't know. Cosine involves the adjacent hypotenuse, the hypotenuse I don't know, so I'm going to have to use tangent to find the size of theta. So tan theta degrees is going to be OR, opposite over adjacent, 5/8. So now we're at the point where we need to work out what we do know, because we don't know what the angle is. So 5/8 on your calculator 5 divided by 8 is 0.625, and at this point, if you're using algebra, you would want to divide by 10, because 10 and the theta between them is like a time sign, you could say. But your calculator doesn't let you do that, so you need to use inverse tan in this case instead of dividing. So the angle is going to be the inverse tan -1 of whatever 5 over 8 is, which was 0.625. So if you go into your calculator and press second and press inverse tan and then type 0.625 and press enter, you will get 32.0054 to 4 decimal points. So that is the number of degrees. That's how many degrees the angle is. Your calculators on the iPad, you might need to actually press 0.625 first. So on iPad calculators, most of them, when you're using inverse tan, you'll need to put 0.625 and then tan -1. So I'll do that right now on the iPad. So it asks you to put in tan -1 first, although it doesn't work if you tan -1 after. It doesn't work the forward way. Yep, so on your calculators on the iPad, you need to do 0.625 first, and then tan -1 will give you the same answer. 0.0054 degrees. So that is an example of finding the angle, the unknown angle. Let's try a different one. What about this triangle here? Theta is down there, 3.17 meters, 5.88 meters. Let's label the sides. So theta is there. This is the hypotenuse because it's opposite the right angle. This is adjacent because it's next to the angle of interest, and this is opposite here. So SOHCAHTOA, we need to use the ratio that involves the two known sides. We know that adjacent and hypotenuse, so this cosine must be what we need. So cosine of theta is going to be adjacent over hypotenuse, 3.17 over 5.88. So I'm not going to actually work out 3.17 over 5.88. I don't want to lose accuracy by rounding straight away. So what I'm going to do, theta is going to be cosine, the inverse cosine of 3.17 over 5.88. So access the second function of the calculator, 3.17 divided by 5.88. On your calculators on the iPad, you need to do 3.17 divided by 5.88 first, find the answer to that, and then press inverse cosine. And so theta comes to 57.3765 degrees to 4 decimal points. So that is an example of, another example, using a different ratio of using the inverse ratios to find the unknown angles. So hopefully that helps you out, those two examples there, and I'll see you in the next video.